guys and girls and whoever. Good morning. It's me, Soldier Girl, back at my workbench. And yeah, I'm kind of happy to be back at the workbench. Oh, I need to get my little keyboard. Here. Yeah, I've been working on this tutorial like forever, and now I'm happy doing some work again. Actually working on my own stuff. And what I want to do today is I've got this connector. You can see here it's this it looks similar to a mini SCSI thing, and it actually is a connector for the Atari Portfolio expansion port. And these, I don't know if you can buy them anywhere these days, but what I want to do is I have this PCB, which is just what we call Lochraster. It just has these copper points on it, through holes, and yeah, they're really handy for doing prototyping. And what I want to do is put this connector on it and make basically a universal PCB for using with the portfolio as yeah, for development basically. I have a few things that I want to try, and it's just gonna be much easier once I have it on a PCB, instead of just wiring each chip in manually and then having to like solder wires all the time. But there's gonna be quite a bit of customization I have to do to make this happen, and that's what I want to do today. Basically just preparation. And the first thing is I have this flash chip. Yeah, you can't see it at all. It's an Atmel 80, I think 8028 C64B. And what it is, it's an 8 kilobytes flash EEPROM. And I also got this socket, which is kind of nasty and dirty. You can see there's shorts all over the place. I desoldered that from somewhere that I'm gonna salvage and put on this PCB and then hook up to the expansion bus. And I want to try and get this chip to work as a B drive basically, because as some of you might know, the Atari portfolio has like the normal portfolio anyway has a built-in memory card slot on the side where you put in a memory card and it's an A drive, and then you can add a memory expander unit, and that will act has 256K of RAM additional, and also comes with a second card slot, which then acts as a B drive. And I already, from my personal portfolio, I already removed the A drive completely. I just removed the slot and replaced it by a compact flash. And now I will try and get this thing working as a B drive, just to experiment with it. I want to try if it's possible to write to it, because the datasheet says it's accessed like SRAM, and these memory cards, they're basically just SRAM chips. Mm. And yeah, I'll get going while I talk. So the portfolio just expects SRAM chips, and the pinout for this memory chip is actually almost the same as an SRAM chip. But I'm not so sure about the timings, because I have checked the datasheet and it's like you can write 1 byte at a time, but then the write cycle takes like milliseconds to complete, and that's quite a difference in comparison to SRAM. So I expect there to be some problems there. And there's also this thing that most flash chips have, that's called software data protection. And that's basically like write protection that you can turn on and off using a special sequence of bytes that you write to the chip at certain addresses. And that's a standard sequence. It's defined by JEDEC, and you have to, it's a 3-byte sequence where you write a certain byte to a certain address, and then if you do 3 in the right order, it locks or unlocks the chip. And yeah, of course, if it's write protected, then the portfolio will not be able to write to it. And because of that, and also because of the timings, I expect that it might not be possible to just write to it like a normal B drive. I might have to come up with a software solution for that. Basically write a tool to flash the chip that may be necessary. I actually kind of expect that to be necessary, honestly. But it's not gonna be a problem. I'm only using an 8K chip, and that's gonna be rather easy to. What I plan is I'll just have a program that takes the contents of the C drive. For those of you who know the portfolio, you'll know that it always has a C drive, which is basically a RAM disk in the main memory. And you can change the size of that, and the lowest you can go is 8K, so you can have a 8 kilobyte C drive. And 8 kilobytes sounds ridiculously small, but actually it's not that bad. It's enough to store like 1 or 2 device drivers. I have on my portfolio, I always set the drive to 8K just to have the max amount of memory free, because yeah, it's a RAM drive. It uses the main memory, and so I have expanded the memory in my portfolio, of course. Originally it has 128 kilobytes, and mine has 512. But still, yeah, more RAM is always nice, so I try to keep the C drive as small as possible. And I also have integrated A drive, which is 1 megabyte, which is huge for the portfolio. And I store all the programs and tools there. And the C drive is basically only holding the driver for my compact flash card, and the CF card has 2 partitions of 32 megabytes each, and that is like in terms of the portfolio, that's ridiculous huge. It's just overkill. And even if it's just a 64 megabyte card, which is in terms of a compact flash card is tiny, but yeah, it's more than I'll ever need. So I'm totally fine with that. Um, and yeah, so what I want to do with this flash chip is there's one little problem, and that is even my 1 megabyte disk and everything else, like the C drive and everything, it's just battery backed. And once your portfolio runs completely dry in batteries, or you remove the batteries for a while, you lose all the contents on there. And yeah, of course, I can save my files to my compact flash card and they're safe and everything. The problem is I need a driver to access that compact flash card, and that driver is stored on one of the memory disks, and that means every time the battery runs dry, I have to hook up the portfolio to my DOS PC and copy the driver back on so I can access my compact flash card again. And this is quite annoying. Especially when it happens on the go. I mean, I have modified my portfolio so I can charge it using USB, and so that's not a problem. But the point is, I don't have a DOS PC at hand all the time, and so I want to have a way to basically store the compact flash driver without needing a DOS PC each time. So, and while I was talking, I have already cleaned up and made the socket ready to go. Now what I have to do is reshape this PCB, because I want it to be able to stick in the side here, and that means I have to shorten it, but only a part of it. Of course, I could just break it off and have a strip like that, but yeah, I'm not sure if I'll actually do that, because then I'd have a second strip that I could use for something else. That might actually be a good idea. Initially, I just wanted to break out a piece so I could stick it in the side, but I'll never need so much space anyway, so I might just split it in the middle. That might work. Let me just I'm not gonna start counting these. So that's 10. So 5 would be here. Let's say a bit less. Yeah, that'll be just fine. So I'm gonna break the board here. And you can't see it, but I just put a little scratch in the PCB so I know where to break it. So yeah, what I wanted to say is my plan is to make an 8K C drive and use that basically as an image, and then just write a little tool that just copies over the C drive to the flash chip, and then I will be able to just copy anything I want to have on the flash chip on the C drive, and yeah, I have to scrape off the contacts on one side because they don't match up if you look at it like this. you can see these contacts are totally, if I just solder it on, it would be shorted all over the place. So I have to scrape off the solder points from one side. I'm gonna use the C drive basically to create an image, and then I can put like all the files on there, and then I'll write a little tool that just copies the whole C drive 1 byte at a time to the flash chip, or rather this chip has like a page write mode where you can write 64 bytes at a time. And yeah, that'll be, if I get it working like I intend, it'll be rather nice because I can just copy all the files I want to my C drive, run the tool, and it's gonna flash the chip, and then I can put the chip back into my programming device on the PC and take an image, and then I can just flash a whole bunch of chips with that, because I want this to be part of a bigger project. You know that I have modified my portfolio a lot, or yeah, if you're a new viewer you don't, but it's extremely modified, and I have this compact flash slot and a memory disk and everything, but it's all wired in there with tiny little copper wires, and I just glued the chips to the main board with double-sided tapes mostly, and it's a bit of a mess, to be honest. And it works, it's fine for me, but it's not something that some random people would be able to replicate. So I want to find an easy way that more people can benefit basically from the work I did and all the possibilities. And my idea is I want to create a PCB that would replace the card socket. Let me just show you on this disassembled portfolio. Like in a portfolio you have this you have the card slot here, and this whole plastic piece is where your memory card slots in. And on my portfolio I just removed that and used this screw to fasten a compact flash slot, and then I had to modify the case a little bit to allow the card to slot in. And then there's a whole bunch of wires and other chips that I just glued on here and wired in. And yeah, that's all fine and dandy, but no one's gonna rebuild that, and so all the work, it's just for me, it works for me, but that's it. No one else is ever gonna benefit from it. So my idea was I'll make a PCB that has solder contacts just fitting these over here, so you can just remove the card socket, put in the PCB, and it will have through holes lining up with these, so you just have to solder in straight wires one by one, and then there will be all the electronics on the PCB, and there will also be a soldered compact flash socket on the PCB and everything you need. So it will be like you will have to run one single wire from the expansion slot over to the PCB, because There's one signal missing, the IOM signal that tells the portfolio to use if it's doing memory or IO access, and that signal isn't present over here. And I'm not sure if you can get it anywhere on this side of the mainboard. What I think is it's on the back side of this connector. So yeah, it will take a bit of work to get it working because you'll have to tap into that single one signal. But other than that, it's gonna be really easy. And there's not gonna be a lot of wiring. As I said, it's just gonna be one single wire and then these contacts that will be just through holes. So yeah, that's what I'm thinking, but it would be rather useless if you still have to copy a driver every time. So I'll have to come up with a solution that makes it possible to have the thing work without needing a driver, without needing an external PC. And the best method I can think of is just have a flash chip that has the driver on it, and whenever you turn on your portfolio, it will be there. Um, I'm not sure if I can make it work absolutely seamless. There's a way. Um, the the manual, the technical manual, uh, talks about BIOS extensions, so you can have a ROM that gets loaded automatically whenever you power on the portfolio, and that would mean you wouldn't even have to put anything in your config.sys file. And yeah, that would be really convenient, but I'm not completely sure if I even want that. It might be more convenient to have it be a driver file that you put in your config.sys and install that way, because if you don't have a RAM expansion, you might want to save the memory. The compact flash driver only takes up like 2 point something kilobytes, so that's not so much. But then again, I might put different drivers on there, like for example, there's a IDE driver, and then there's a driver for zip drives, and you don't need all of them. And you might want, for example, to have your compact flash driver installed, but not your IDE driver, because the IDE interface goes through the parallel port. Or you have a zip drive that you don't always use, and so you might want to switch one of them on or off. So if I have only a data drive basically, and it has just the files on there, then the user could just turn on and off the ones he wants to use, and don't waste any RAM. So I just removed the copper contacts right in the front there, and now I'm going to use a piece of wire that you can barely see at all, and basically fasten the connector. I don't want to glue it because I might want to take this thing apart someday. So I'll just take this piece of copper wire and twist it on here. Sorry. Ah, sorry. Excuse me, they say. Um, yeah, so this is not gonna be permanent, it's more temporary. Because as I said in the beginning, these connectors, I don't know if you can buy them at all anywhere. And even if there's some source, I don't know it. I have no way of getting another one, so yeah, I just want to have the possibility to remove it again. And I think this... Oh, yeah, I broke the wire. Of course. Because why not? Oh, YouTube is warning me that my audio has a bitrate of 0. Yeah, but the audio is working, so that's just YouTube being weird. Yeah. So yeah, what this is going to be is basically just a flash disk that will make it possible to have your driver's installation without needing a separate PC. And if it turns out there's a source for these things, then we could even make a tiny little module, because this chip is rather big, but you can also get them in a tiny SMD package. That's like, yeah, I don't have one around here right now, but these are really tiny, so you can get a really small one. And it would be possible to make a really just a small like dongle that you could put in your portfolio and have your files there all the time. It's like the in the there's a Facebook group of portfolio users, and they're developing a an IDE interface right now, which is great, I think. And they are dealing with the problem of drivers by just supplying a memory card with their device. But of course that's only gonna work if your portfolio still has the memory card slot. And mine doesn't, so this wouldn't work for me anyways. So now I'm thinking just adding it like this, and then I'll have a ton of space left for doing other stuff later. Well, I'll leave a bit more space so I can like add some jumpers here maybe. Yeah, I think that's gonna be fine. And I'll be left with a ton of room for stuff that I might add later. Yeah, that's gonna be fine. So And yeah, if this actually works out, then it might be possible to include something like this into all sorts of devices. Like, as I said, I'm thinking about making a PCB for a compact flash mod, but also I want to try using the this BIOS extension thing, just to see how it works and see if I can get it working. Because like for my yeah, you might know if you're following my progress, I have a microchip PIC MCU inside my portfolio, and that's semi working. And once I get it fully working, um, I will want to have a driver for it that integrates it into the system, because what it does is it's monitoring the battery voltage and also controlling the brightness of the LED backlight in the display. And yeah, I will want to have that integrated in the system and not use a special tool all the time. So yeah, I'll have some work to do there. So now what I have to figure out is, yeah, it might have been smarter. If you look here, there's this marking that marks pin 1 and I think it might have been better to put that on the top, but yeah, whatever. I have the technical manual here, and I can just figure it out from there which one is pin 1 and then go from there. Okay, if you're looking into the portfolio like that, the top on the right is 1, so this is gonna be pin 1, and the bottom is pin 2, so that's all I need. That's all I need to know. And I have the pin out on my screen here, so I'll just figure it out from there. And pin 1 is, I don't actually need that at all. I think I'm gonna start with the data and address lines. Yeah, there's a PDET, which is peripheral detection. I think I'll need to pull that to ground. Yeah, I think yay. So I'm just gonna use this little jumper block over here, and I'm gonna use that for tying some of the signals to ground just as I go along. Because there's some signals that I will have to pull to ground, basically to tell the portfolio that there actually is a card drive, and then also have to convince the portfolio that there's a card in the card drive. And that's done by pulling certain signals to ground. And I'll just use jumpers for that. And I might also add pull-up resistors, maybe, possibly, I don't know. No, I think I will not need that, but who knows. So yeah, one side of that is just gonna be ground. So maybe it's gonna be smart to just start from the ground, so to speak. Which means I'll have two. Let's see which one is ground. Oh, that's on the top here. So I just start from ground and go from there. Yeah, I might also need what's called a PLD, basically a programmable logic device that allows me to have address decoding and stuff. I mean, yeah, you can always use not just standard logic chips, but then you're basically locked in one function, and these are small. This just one like this, and I could, yeah, it would fit here. I could make that work. Of course, I don't want to put the chip in the board because it needs to be programmable, which means it needs to be removable. Let's see, is this that's too small. I don't think I have one of these sockets left. Excuse me. I'm not sick, it's just very dusty in here. I'm just looking around to see maybe I have one of these sockets somewhere. I'm not sure. I don't think so. Yeah, it's a shame. I think I really don't have any sockets left. Yeah, that's a bummer. As they say, yeah, that kind of sucks now. Because I think I'm gonna need it. to decode some signals, because I want the flash chip only to react to certain at certain times. And yeah, but I'm gonna wire everything else up and then go from there. So let's first start with a ground wire, and yeah, now I have to let's go by the numbers. So this is pin 1 is A buff, then some ready, beacon, NMD. What's NMD? Is that the memory drive thingy? Yeah, that's one I'm gonna need. And I'm also gonna need the NCC one. But that's on the back side. But on the front, I'll need the yeah, the NMD I'm gonna need. That's pin 7. So that's 1, 3, 5, 7. That's the one I need. And I'm just gonna use, these are just leftover wires from something I did earlier. And what I'll do is I'll just use these as jumper wires. And have that go on there. Let me just grab my tweezers. Yeah, I'm just gonna run all the wires around here so they don't get in the way when I later add more wires on the bottom, and also when I finally at some point I'll have to add a socket here, and so I'll have to make sure that these wires don't get in the way. And it's always when doing freestyle wiring like this, it's always important to make them as orderly as possible, because it gets messy all by itself. Even if you try to make it as orderly as possible, it will get messy, so better try to keep it somewhat orderly. So this is gonna be the first wire on this jumper block. And then I'll be able to just place a jumper there, pull it to ground, and tell the portfolio that there's a card available. So now the next thing up here that I'm gonna maybe need is let's see, that was there's a DTR. Yeah, so I'm gonna need this DTR signal on a chip later. Yeah, I'm definitely gonna need that. Hmm. Because some of you might know there's like you can read or write, or the CPU anyway can read or write from and to devices, and there's a signal, but memory chips, they have one signal for read enable and one for write enable. And since the CPU only outputs one signal, but I need two signals for the flash chip. That means I need an inverter somewhere in there, and that means that's gonna be my PLD, and I actually really need a socket for that. So I'll have to come up with something right now. And this is just one of these things that always happen when I start building stuff. Because I actually don't have a lot of money, which means I can't just go ahead and buy a ton of parts and have them laying around in case I might someday need them. I basically just buy the parts that I absolutely inevitably need, and everything else I try to make up as I go along, which doesn't exactly make things easier, but yeah, some of you might actually be in the same position and have to figure out stuff. Yeah, that's one socket I don't want to slaughter. I had a socket lying around there. I distinctly remember seeing one socket that was, of course, the wrong one, but this piece, and then I have this chip, and I had another socket somewhere here. Because you can always reshape these sockets. Reshape is a nice word. Um, yeah, I think at one point I'm going to have to order some parts, including some sockets. Yeah, I guess just hearing me rummage through my stuff piles isn't very exciting. Come on. It's unbelievable that I don't even have one single socket left. But I'm not willing to let that stop me. And I know that I just had I saw a socket here. Yeah, maybe I'll just have to butcher the big one. Yeah, why not? Whatever. I don't care. I have this card I built for a different project. It was, it's basically, this is a connection to the ROM slot of Atari ST, and then I wired it up, as you can see here. So you can put ROM chips in here, and basically for trying out different kinds of circuits. And what I gotta do now is I gotta butcher this poor little socket to make it work for this chip. And I already have this pre-butchered socket. As you can see, this is not the first time I'm doing this. And what you do is you just cut it and then place these right next to each other. And then they will fit a smaller chip. But of course these are too short. So I will need more. I need a bit more. So this is 1, 2, 3, 4, 5, 6, 7, and I need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I need 3 more on each side. I could just cut this one up, but I'll just take. The point is that you cannot. These are not made for being disassembled like that, so it's a bit of trickery, but yeah, it works. As they say, if it works, then it's not stupid. And in that regard, this isn't stupid at all. So there I have 3 more pins. Now I just have to make them fit right next to each other. They need to have the right spacing, and I think I'm gonna do it like that. So just cut off the excess here a little bit, make it cleaner. Also on these. Then cut out the middle piece here. And then what I'm gonna do is I'm gonna take some random chip that's roughly the same size. Maybe this one? Yeah, that's whatever. And I'm gonna put the sockets on the chip like this. And then I'm gonna solder them onto the PCB with the chip in like that. And that way I know it will fit perfectly. And I don't have to worry about the spacing or the thing sitting straight and everything like that. So I just use this as a guide, put it in somewhere around here, like that. And then of course, oh yeah, I'll have to trim off a bit more in the middle there. because they're not sitting right next to each other as they are right now. So what I'm going to do is I grab a trusty file and just file it down a little bit. Just to make them sit next to each other a bit more nicely. This one looks good. Yeah, this one has a huge bulge on it. And of course I'm doing this so that no one else is gonna have to. Because as I said, if this actually works as I think it is, then I will one day come up with the actual printed PCB. Oh, that's kind of double there. PCB stands for printed circuit board, so a printed PCB is like yeah, that's kind of stupid to say. That's like saying PCB board or CPU unit, something like that. Well, now I have a random cat rummaging around here. Hey, cat. Okay. So now I should be able to place the socket here. Maybe more like here. Yeah, that seems to be about right. Yeah, that's gonna be nice. That'll work. So yeah, I'll have to run a bunch of wires to this chip as well. But I can program the chip to do whatever I want, so that's not gonna be a problem. So I don't have to follow any given pinout because I can define the pinout myself. I just have to wire up the voltage supply to the right pins, and everything else is gonna be defined by me. And I use the same chip for my PIC as an address decoder. That's so I know they work. It's always when working with stuff like that, it's always a little bit tricky, or yeah, not tricky basically, but you don't always know if the timings are gonna work out, if your chip is maybe a little bit too slow, or if you're working with old systems like the portfolio, you don't know, yeah, maybe even the system timing is too slow for the chip to handle, and but I know that this chip works, and I have another one, so I'm gonna use that. So now I have that. I'm just gonna remove the chip out of here. Okay, it's not very stable. It's not stable at all, to be honest. And I kind of don't like that, so I actually want to do something about it. What that's gonna be is I'm gonna use some electric tape. That's gonna run around this improvised socket to hold it in place. And I think maybe filling the middle in between the chips with some hot glue, maybe? Yeah. Sounds like it would do the trick. I'll just put some random chip in there for now to see if I... Okay, wait a minute. Yeah, if I put a chip in there, I'll not be able to fill the thing up, of course. So oh yeah, electromechanics. Okay, that's gonna work. Get this thing out of there again. Okay, that's gonna hold it in place for now. Now I have to trim off the excess. Just gonna cut most of it away here. Just roughly cutting along the edge of the socket. position there. Now I gotta heat up my glue gun. Let's hope that this doesn't break anything. I got a serious lack of power sockets left. So I just want to put some hot glue in between these two sockets just to stabilize the parts together. That's gonna help. And while the glue gun is heating up, I might connect the next signal. So I had this NMD1 and the next is DTR. And DTR is the data direction. That needs to go to the programmable chip later, so I'll have that wired. Okay, no shorts there. And I'm not gonna wire that up to anything just yet, because it will depend on the pinout of the chip actually, so I'll just leave it hanging like this. So now I have a heated up glue gun. It's always a bit tricky working with this thing because it's not the most professional tool. But I think that should work. It's just for stabilizing these two half sockets basically. So once this is dried out, it should keep them nice and stable. So I have the data direction signal, and that just gonna need to be inverted later, so there's not gonna be a lot of logic on that. Then I have a peripheral detect signal. I'm not gonna need that. Then there's a clock signal. I think I don't need that as well. Hold IO back. For now, I think I don't even need the IOM signal. I mean, yeah, later I might do some things with this board, but for now I don't think I need any of that. Then we get to the address lines, and I need A12. I need everything up to A12. That's pin 27. That's gonna be the next one I need. So, since that's quite a high number, I'm gonna need quite a long wire. And my scraps are just not gonna cut it for that, so I kind of messed this thing up. Trying to whatever. So this is the first of the address wires, and since I'm only using an 8 kilobyte chip, I'm not gonna need all of the address wires because it goes up to A19. Okay, so I'll need pin 27. 1, 3, 5, 7, 9. 13, 15, 17, 19, 21, 23, 25, 27. So this is gonna be A12. Wraps around like this and goes to pin 2 of the flash chip. It's gonna run that way. And then pin 1 is gonna be not connected. And I need to go to pin 2 here. course, one could use a bigger memory chip for this, but this 8K is just the one I have. It's gonna be fine. As I said, like this, the driver I care most about is like 2.6 kilobytes or something, and I guess the other ones are, I think the IDE driver is even from the same developer. It's a derivative of the compact flash driver, because basically the compact flash is IDE. It's just a little bit simplified, I think, because the compact flash driver, it connects directly to the main board, the device, I mean, whereas the IDE runs through the parallel port, and so it needs to drive all the signals through the parallel port chip. And what I'm gonna do now, before going on, I want to wire up the ground here, just because I'm gonna run a lot of wires along there, and soldering around on it later is not gonna be a good idea with all these animal wires. So what I'm gonna do is just run one long piece of wire along the one side of the jumpers. Yeah, just like that. And then I can connect that to ground later. And that's always what happens when I start working on a circuit like this. It's always like I have to put wires somewhere, because that point or that thing will be hard to get to later, or won't be a good idea to solder around on later. And then I end up with a ton of just random wires hanging out of everywhere. And that can get very tricky to keep track of that, honestly. It's not gonna be as bad in this case, I think, because there's only few signals that I cannot wire directly. That will have to wait for later, but yeah, there's gonna be a few, just like this one. Okay, so I think the hot glue in here is dry, but you know what? I think I'm gonna keep the electric tape around the outside, just trim it off a bit more. And this is just some cosmetic work. It doesn't, functionally it doesn't actually matter. Oh, I got a little bit of hot glue on the sticking out here, the side. Ah, yeah, no, what the crap. Just get rid of this. It'll be fine. Yeah. it works. It's not the most pretty thing, but whatever, it's gonna work. So I've got that grounding thingy. Now, what's the next signal? That's A12 wired up. The next signal here is A10. And I gotta go, as the Americans would say, I gotta go wash my hands. Okay. So, the next signal, A10. That's gonna do it. There's some common things in wiring up stuff like this. It's always a bunch of address wires and a bunch of data wires and then some control signals, and then you're good to go. And you might notice I'm not following any circuit here. I actually don't like drawing out schematics and then following them and then finding out that I made a mistake and then redrawing it, maybe even like draw a circuit and then make a PCB and then find out I made a mistake and make another PCB, and that's just not the way I like to do things. I just have a screen right there, and there I have the technical manual for the portfolio where I have the pinout and the signal description for the expansion port. And right next to it I have the data sheet of the memory chip with the pinout open. And then I just wire the signals one by one as I go along. That's just the way I do stuff. And then if it turns out to be working, then I draw a schematic later, maybe. Or in this case, I might one day do a PCB. Okay, I need it on this side, so I'll run that along pin 21, which is 50. Oh, wait a minute. I have to be careful. I have to count from here. That's gonna be 28, 27, 26, 25, 24, 23, 22, and 21. It's gonna be this one. And what I'm gonna do is just stick a bit of wire through here, bend it over just as a marker so I know which pin I need to go to, and then bend my wire over there, and then tin it and solder it. I really like these enameled wires because they're very thin and you don't have to, I mean, you have to deal with the isolation in the sense that you have to remove it, but it's not like a normal wire where you have actual insulation that you have to strip off. It's just you heat it up with some solder and it works. And that's just a lot easier than to strip the wire, especially when doing stuff like this. It looks very simple right now. If you look at it, it's just these few wires. But yeah, once I'm finished, it's gonna look a lot different. So that's A10 now. Next is A8. And I'll just run that along the same path, basically. Push them down a little bit. And I want all of these wires basically to run along the same way so they form one big pile in the end. And A8 is gonna be pin 25, so that's on the same side. It's gonna be a bit shorter. And this was pin 28, 27, 26, 25, 24. That's the one. No, I mean pin 25, this one. So take my little marker. 28, 27, 26, 25. Here. That's the one I need. I'm trying my best to bend all the wires in shape properly, because as I said, this is gonna get messy all by itself, so I do my best at keeping the messiness to a minimum. And of course now my marker fell out. 28, 27, 26, 25. Yeah. It's gonna go right on there. One more. And then we got a hose line. I'm not gonna that, and the next one is ground. Gonna need a ground, that's for sure. And the ground wire needs to go to a bunch of places. And ground is always a little bit special because a lot of things need to be connected to ground. So you always have to plan for additional connections. And in this case, what I'm gonna do is I'll use the jumper block that I already wired before as a kind of a connecting block. And the ground wire I'm not gonna run along the top, I think. But instead I'm gonna run it through the PCB right here and have it come up there. Or should I do that? Nope, nope, nope. I'm not gonna do it that way. I'm gonna follow the pattern, just pull it along. It's gonna work, it'll be fine. And I just connected to the jumper block here, and then I can connect more wires to that later as needed. And I just do that because this there's already a bunch of solder joints there, and what that basically does is it makes it so that I can solder on one spot of this whole line there without melting it all, so I can solder a wire to it on one side without the other side of wire popping off, which is always convenient. So there we go. That's our ground hooked up. And the next thing is OA7. And OA7 is a latched address line. And I'm gonna need A7, of course. That's one thing about the x86 architecture. I don't know if the latest x86 CPUs still do this, but basically the early x86 CPUs, in this case we're dealing with the 8088, which is just an 8086 with 8-bit data bus instead of 16. And what they did is they used, basically Intel wanted to save some pins on the package, and so they used this address latch where the data pins can also have address data on them, and you have the address lines 0 to 7 on the data pins, and then there's this address latch enable signal that basically you hook up 8-bit register to it, and whenever this address latch signal is active, then you just have to save the 8 bits from the data bus to a latch and use them as the lower address lines. And pin A7 is right next to A12, which is right here where we already have a wire. So that's nice and convenient. Another one. Okay. So that was A7. Next we have A5. Go. Let's go A5. And it's basically, in theory, it wouldn't even matter if I were to just if I just wanted to make this work somehow. The order of the address bits wouldn't even matter. Like when I did my RAM disk, I didn't pay any attention to which address line I put on which address line. It's just they have to be unique, because what that changes is just the order of the bytes in the RAM chip. And yeah, it doesn't matter at all for just accessing it. But in this case I want to use this as a master, and I want it to be replicable, if that's the right word. Replicatable, whatever. Basically I want to use this to create image files, and that means I have to actually put the address bits in the right order. for my RAM disk, it was completely arbitrary because, yeah, the data is not coming out of that chip at all. It's just the address lines have to be unique so that whenever the CPU writes data to some location, it will retrieve the same data later, so it doesn't actually matter if it's completely messed up. It's just in this case because I actually plan to make a PCB later and then use copies of the image I create on this little device. Because this is a very simple two-chip solution, and it might be possible to make that extremely tiny with SMD parts, so that might be actually useful for other people later. As I said, it might even be possible to make a tiny little dongle that just sticks in the side of the portfolio and gives you this little ROM drive that you can get your drivers from. That's the idea, basically. Okay, that should have been. Let's just make sure we're at the right wire. So this is 1, 2, 3, 4, 5, 6, 7, which is A3, and that's on this side. Let's count from the back just to double check. 59, 57, 55, 53, 51, 49, 47, 45, 43, 41, 39. That's not right. I made a mistake. Bum, bum, bum. Okay, so 3, 5, 7, 9, 11, 17, 27, 9, 31, 3, 35, 39 is A5. So I did something wrong here. Oh, I should have skipped that one. I just got that wrong. So, and I think that's the one I put on ground. Okay, I'll have two. Yep. I put the ground line on the wrong position, which really sucks. Because now I have to move them all over by one, and they're not long enough. So I will possibly not be able to do this in a nice way. Let's see if I can just force it over. Someone said if brute force is not working, then you're not using enough of it. Okay. One more. Yeah, and that's exactly why I always like to, I mean, what I did was I just kept counting the wires one to the next, and somewhere I forgot to skip one, and that would have been my downfall. But then, just to mix things up a little, I counted from the other side of the connector, and that made me realize my mistake. So that's one thing that I learned. A real professional, you don't it's not that a professional doesn't make mistakes. It's the point is that a professional will notice his mistakes and be able to correct them. So now that should be, that one should be A3, and that's pin 41. So let's go 41, 43, 45, 47, 49, 51, 55, 53, 55, 57, 59. That's right. That's just what I need. So the next one is A1. And more wire. a lot of copper on this thing. And I have thinner wire that I could use, but I like this quote-unquote thick wire because it's easy to bend and it stays in shape. So this is A1. Now I have to okay. On the socket here, I'm just skipping every other one because the address lines are in order, and on the expansion bus they are actually also in order when you go by the pin numbers, but the numbers are different. And now I got a huge blob of solder on here, which is not good at all. I have to get that off. Yeah, that's just what happens. You have to remove it. Okay. Now the wire has got to go here. So cut it there. I think it's always a little bit amazing that actually people find the stuff I make amazing, because it's it's not hard. It's just it requires a lot of patience and going step by step, double and triple checking everything, and that's basically all there is to it. Go slow, be patient, double and triple check everything. So that was the line A1, and now we get to D0. So this is the first data line. Still follows the same pattern on the flash chip. Gotta leave out one pin because that one pin is A0 on the chip, and the next is gonna be, it's labeled IO0, which is the data pin, and on the chip they label it IO because of course the chip can input and output on these lines, so but the wiring should be almost halfway done. We have D2. More wire. And I think after I'll do that one side of the connector and then take a little break, maybe do something different, drink a bunch of coffee, watch a YouTube video or stuff like that, and then get back and do the rest of the connections later. I want to get the thing wired up today. Not necessarily get it working, but just get the soldering done. And I have to like program the logic chip, write the test program, all that stuff. I might do that tomorrow. And since I'm working again, I always try to do stuff like this that takes hours at a time. I always do these things on the weekends, and then under the week, as we say, I can just basically write a bit of code and do stuff like that. The easy stuff. So the next pin is of course skipping one, and that pin is gonna be D2. And then the very next pin on this chip is gonna be ground, which I'm gonna use the wire that I have dangling off here and just run that around down here and in here, but I'm not gonna cut it at that point. But what I'm gonna do is I'm gonna bend it over like this. Sorry guys, my Wi-Fi just cracked itself. And that keeps happening lately, more and more. And the problem seems to be my Wi-Fi dongle. So I might have to replace that at one point. And I'm actually thinking about not using USB Wi-Fi anymore. I really don't want to run wires again. I used to have wired internet or wired network at home for a long time, and I just don't want to have to deal with cables around my apartment anymore. So if this Wi-Fi problems keep happening, then I might just have to get a PCI Express Wi-Fi card, even though they're a bit expensive, I think. Especially if the point is my PC is I have like a window case and everything, and I want it to look really nice, so that means I absolutely do not want to put some ugly green PCB in there. If I put a card in there, it should match the color scheme, which is black and red. And there's only one card so far, or one series of cards I should say, that matches that, and they are ridiculous expensive. And that sucks, because I'm not rich by any means. So I'll just have to deal with this crap for the foreseeable future. Or Or maybe I'll actually one day go back to having cables. I don't know. Okay, now where was I? So I've wired up ground. I was at D2, now the next one is D4. And D4 is gonna be on the opposite side of this chip. It's gonna be this. Was D4. Now we have D6, and then 4 more pins. Yeah, that's just right. And the other ones, I think I don't need any of them for what I'm trying to do here. That is because that's something with interrupt and external voltage and stuff like that. And I'm not gonna, I think I don't need any of that. Gonna read the signal descriptions in a moment, just to make sure. This wouldn't be the first time where I thought like, oh yeah, I don't need that, that's fine. And then it turned out that that was what prevented it all from working, so I'll double and triple check, of course. this is D6, and that's gonna go there. That's one more down. And now, if I'm not mistaken, I should be fine. At least for this side. Let's see. E in, this external interrupt, I don't need that. Vx is external power supply line. In theory, I should use that for the, or I could. Better line that D and 5VS. 5VS. I could use VX or 5VS. One of the two. I think I'm gonna take the 5VS for my supply. And wait a minute, there's a second one on the back, I think. Yes, I can just take that. What's VCC? The credit card power supply. Yeah, I'm not gonna use that. I'm gonna use the 5VS, I think. Yeah. So I think I'm done with the top side, and as a last step before taking a break, I'm going to use a bit of this cut-off wire to tidy up my wiring here, which means I just stick it through the PCB here and then twist it together on the back side, and that will hold the wires in place and force them into a somewhat orderly shape. Yeah, I have to go one step back. Come on, go in there. That's perfect. And then the other one is there, like so. And I don't want to grab onto that one, so that's gonna go around here. And twist that together. And I'm not gonna twist it really too tight, it's just because this is not for mechanical stability, it's just to keep the wires together and keep them from dangling around all over the place. Yeah, that's nice. And then I'll do the same on this side for the this strand of wire going over there. Just push it in from this side if I can. Yep, I think there we go. Twist that a little bit. There we go. That's it. That's the top side of the wiring all done. Going from the connector around the edge to the memory chip, and one of them goes to the jumper block, of course. And now all the remaining signals are on the bottom. And then I'm gonna have a memory card that I can just plug into the portfolio, which is kind of awesome, I think. Just for a little test, let's see if it actually works, like mechanically works. If I push it in, okay, in the long run I will have to Ah, okay. Ah, I see, I see. These pieces are in the way. I have to bend them inward. And around this little corner here. Now that should work. Yeah, it might have been a good idea to check that first before wiring it all up. But I might, once it's finished, I might just go ahead and oh, wait a minute. No! I'm so stupid! This is a directional connector. I did it all wrong. Okay, wait. I'm not gonna give up that easily. In no way I'm going to redo all of that. I might actually have to. Yeah, but I think it's time to take a break, ponder my existence and my stupidity and fallibility, and yeah. I might stream again later. See you guys.